Hi, this is a supplementary lecture on how to conduct data analysis for the Executive Black Belt course. Week 3 covers the slides 2 through 15. Now we're going to be doing this mostly on the Blackboard, so no need for the PowerPoint. So let's talk this through, and keep in mind that we're talking about analysis only, not the data collection. Okay. So this presumes that you've somehow collected the data, you've got it, and it's time to take a look at it. So what I wanted to do is kind of walk you through something that I'm going to call the data analysis algorithm. And I'll tell it to you first, and then we'll go through how to do it. And in the next section, we'll go through lots of examples. So the algorithm basically goes like this. It's dependent on two things. It's dependent on the number of variables that you're interested in, and it's dependent on the types of variables they are. Now, you can look in the stats book and you can see lots of different types of variables, but we're going to focus on only two broad generalizations or categorizations of them. One is called a categorical variable, or a CAT. Okay? And these are things like eye color, hair color, whether you're a Republican or Democrat, if you're in the U.S., whether you like fishing or you don't like fishing. Those are things that are either yes or no, or there's only a certain number of them, right? Like eye color. But there's no inherent difference between, say, the brown or blue eye color in terms of numerical value. Now, I guess if you're an engineer, you can say, well, there's a certain wavelength that they're reflecting. But for most applications, we're not interested in that. So these are things that you essentially can't do math on. You can only categorize them. And that's the key thing, is you can't do math on them. And by that, we don't mean like counting how many are in the categories. What we mean is we can't subtract, we can't add, divide, and have the numbers keep their meaning. Okay? The second type is called a numerical, or a num. We can also abbreviate these with N or C. Numerical. And these are the things that you're normally used to seeing associated with measurements. Things like how tall a person is in inches, or how much they weigh in pounds, or how long a phone call lasts in seconds, or how long a bridge is in feet. All of those things are numerical variables, and they have inherent mathematical value. All right. Suffice it to say that if you have numerical data, you should keep it, because you can do math on it. And that can be, so I suppose, a little bit scary, because there's lots more that you can do with these things. But it turns out that you also need a lot fewer data points if you have numerical data than if you have categorical data, to really kind of see the essence of what's behind there. All right, so that's the lowdown on this. So it depends on two things: the variables you're interested in, the number of them, and the types of variables that you're interested in. Now, I should say one more thing that we're going to make a distinction about that's important for the data analysis algorithm, and that is whether something's an input or an output. But I'm going to help you with that by introducing two props that are going to help you, that are, in other words, they're aids to getting things done. One is the process box. Okay, and that is simply a box where you're going to make the distinction on the left-hand side. This is going to be the output. And on the right-hand side, these are going to be the variables, the input variables, the inputs that you're interested in, the x1s, x2s, x3s, x4s, etc. And this is going to be your y. Okay, and the second prop, so this is the first prop, and this is probably the most important one, and this will help you get by. The second prop is called the PGA wheel. Okay, and this is going to help you keep everything together in the context, in its own context. And the PGA stands for practical, graphical, and analytical. So in short, this is the real-world language question that you'd ask. If you ask it in English, it would be something like, I wonder if X1 drives Y. Okay, graphical means make a plot. You make a picture of it, of what's going on, whatever that is. I just drew a histogram there. And analytical means you back it up with some calculation. I calculate the X bar, I calculate the sigma, I calculate a p-value. We'll learn about that sometime a little bit later in the course. Okay, and then finally, we're always coming back to the practical and making a conclusion. All right, so let's go through what an example might look like on this, and then I'll give you some final pointers. So let's say we are in a call center, and we were interested in a project to reduce average handle time. You know what? I'm going to even erase that average. Let's just say reduce handle time. Okay, reduce handle time. I'll rewrite that. It's important to get it down. Okay, so we're going to reduce handle time. So let's draw our process box. We may have collected data on a couple of different outputs. Let's say handle time. And suppose we also collected data on average speed of answer, how long it takes them to pick up the phone. Okay? Both of those are numbers. I'm going to label them as such. Let's put them in blue so we can read that. These are numbers. I'll just write a num and n. Okay. And now we ask the question, what would these things depend upon? What would handle time and answer, average speed of answer depend upon? Well, it may vary by call center rep, CSR, the person who it is. It may depend on their experience. It may depend on whether they got trained or not. It may depend on their shift, whether they work the morning shift or afternoon shift. And it may depend on many other things, and we could list all those things if we had collected data. That's part of a data collection exercise. Let us now list whether these are categorical or numerical. CSR is the person. Well, person, the person's name, that's a label. Who made the call? That's a cat. That's not a number. I can't add Joe and Jim and get some Joe-Jim. Okay. Experience. That happens to be a number. It probably is a number. It could be measured as a category, high, medium, low. But again, remember, we're going to prefer numbers if we can. So that might be how long they've been with the company in days or months or years, something like that. Whether they're trained or not, that's a cat. And what shift they're in, that's a cat as well. Okay? Makes sense. So then what we would do is we would take one of these outputs, and depending on the question that we had to ask, let's do a couple of these. Let's say that we were baselining our data. So we just wanted to see how one of these, handle time, was going over time. Okay? So if we were just interested in how handle time was going over time, our practical would be, I want to set a baseline. Now we've got baselining coming up in another section. Our graphical might be, I look at the data over time. I look at handle time over time. You know, like what date it was captured on. I look at handle time, and I see if it varies. Or another thing I might do is I might do a capability analysis, as you'll find out, and look at the various handle times with respect to how well they do with respect to a customer specification. Okay, and I'll draw in that customer specification as a red line. Long handle times are bad, so this would be sort of the percent bad that I've got in red there. Okay, and that tells me something about what's called capability. And then finally, I might do some analytical where I calculate something. I might calculate the mean. I might calculate the median. I might calculate the standard deviation. I might calculate the range. I might calculate a 95% CI, whatever. Okay? And I go through that whole thing, and I can make a comment about where these are. And that's my practical. All right, so that's that one. Now let's give another one here. The key thing, though, is that I'm treating it as a number. If I treat it as something else, as a category, I would probably do something totally different. And remember, we have Excel stats to help us decide what some of those things are. Okay, now let's talk about what you might want to do in the analyze phase. That was in the measure phase, but how about in the analyze phase? Okay, in the analyze phase, let's draw our PGA wheel. Suppose we wanted to see, for example, I wonder if handle time, I'll circle this, is a function of whether the person was trained or not, whether the person received training or not. So our practical is, I wonder if training matters, or if training drives handle time, question mark. It's a question. Graphical, as we'll find out a little bit later, we're going to do in this case, we have one num, one cat, so we'll do one num, one cat. Analysis, last time we did one num. All right, so we do one num, one cat analysis, and we'll find out that we'll have things like we'll have mean comparisons, and we'll look at whether or not one mean exceeds the other, things like that. We'll look at those bar charts. We'll look at box plots. And then finally, analysis, or analytical. We're going to be doing a t-test, and we'll be doing a confidence interval, and we'll be looking for a p-value. Now, if that p-value supported that they were different, we would go up to here and say, conclude, yes, it's a driver. Notice I'm being careful about not saying what it is, whether it's a good driver or a bad driver. But in any event, that's how we do it. And once we've got that done, we can either circle these things and say, yep, it's there, or essentially if we don't find an effect, we can cross it off. Let's say we didn't find an effect with the shift. We could cross that off and say, okay, let's move on to more complicated analyses. Or let's see if we can do something with those conclusions that we've already made. And that's really the key. If you've got 10 variables, it's good to systematically go through them one at a time and so forth, eliminate them or keep them, and make your analysis simpler. Okay, so now here's a couple of guidelines. So basically that's the algorithm. It's all dependent, as you noticed, on the number of variables and whether they're numerical or categorical. Okay, here are a few guidelines, and then we'll end this little lecture, and we'll go on to some real examples. One, keep it simple. The KISS principle, right? Keep it simple statistically. And what I mean by that is first start out with one variable, then two, then three, if you need, then three, if you need it, if needed. Our brains handle the simple better, and so if we can make strong, simple conclusions, those are better. So what that means is when you're doing this, start out with just one variable. Later, once you're understanding the output variables, then you'll start looking at the drivers, and you'll look at them one at a time. What you don't want to start out with is something like this, where you're looking at each one of these and you're asking the question, I wonder if x1, x2, and x3 simultaneously affect y. That's a complex question that's difficult statistically to analyze. Okay? So start out with the simple and move to the complex as you need to. Number 2, plot, plot, plot. Okay, and look. One colleague of mine said you always have to look at the plot too. Plot the data, look at the plot. Okay? Do that. Pictures tell 1,000 words, and if you're using the PGA cycle, right, you're drawing these little pies here, you're always doing the G part. Plot that data. Plots are way more important than numerical analyses for understanding. That doesn't mean that the numerical analyses are not important to back it up. Okay, so that's about it. Remember that this was for analysis only, not data collection. And the algorithm is dependent on the number of variables that you're interested in and the types of variables. And the two props that you're going to use are the process box and the PGA model. Okay? You'll use that process box, label each one num and cat, as shown right here, and then you're off to your analysis. When you finish all through, you're done. All right. Hope you enjoyed this lecture, and we'll see you on down the road.